Hello class, these are Algebra 1 notes for section 712. Today we are completing the square, and this is part 1. We'll do this for 3 days. So quadratic equations that aren't factorable can be solved by completing the square. So I know we've spent a lot of time solving, and we like to factor and use zero product property, but sometimes we can't. So these are our steps. First, we're going to isolate the quadratic terms and the linear terms. So remember, quadratic would be x squared, linear would be the term with the x in it. So it could be like a bx. So we want to isolate those on one side of the equation. So that means we're going to be possibly adding or subtracting constants to get those by themselves. So I'm going to write move constants. So a constant would just be a number. It doesn't have an x. Find the constant that will make a perfect square trinomial. This can be done by dividing the linear coefficient by 2 and squaring the value. So that means I'm taking this thing right here, b, and I'm dividing it by 2, and then I'm squaring it. Add the constant found in step 2 to both sides of the equation. So we're allowed to add something if we add it on both sides. We rewrite in factored form. Let's see, add both sides. And then we've got basically a perfect square. And so if we've got a perfect square, we're going to square root both sides, and we're going to go through and solve. So first we're just going to practice making perfect squares. So we're really just doing like step 2 right now. Okay? So let's take a look at a couple examples. So if we have x squared plus 6x plus something, we want to figure out what would fill in the blank to make that a perfect square trinomial. So they're telling us to take the constant, the linear coefficient, so like that's the 6th part of the 6x, and divide it by 2 and square it. So 6 divided by 2 is 3, and 3 squared is 9. So let's just check to make sure that that's actually a perfect square, just to convince ourselves that it works. So if I was going to factor this, 3 times 3 makes 9, 3 plus 3 is 6. So we have an x plus 3 times an x plus 3, which is x plus 3 quantity squared. So you can see why I had to take the 6 and I had to divide it by 2. That's because the 3 happened twice, so I had to divide it by 2. Let's look at the next one. 12 divided by 2. And I'm going to ignore the negative because when I square it, it's going to make it positive anyway. And then I want to square that. So 12 divided by 2 is 6, and 6 squared is 36. And let's just convince ourselves that that works again. So a negative 6 times a negative 6, that multiplies to make a positive 36, adds to make negative 12. So this is going to be x minus 6 times x minus 6, which is the quantity x minus 6 squared. Looking at the next one, same thing. I'm going to quit the factoring step now. We're just going to come up with the number that completes the square. 2 divided by 1 and then squared. Well, 2 divided by 2 is 1, and then we square it. 1 squared is just 1. So make sure that you really believe that. So 2 divided by 2 is 1, and then 1 squared means a 1 times a 1. That's 1. It's really tempting for people to put the wrong number on this one. And the last one, 4 divided by 2 and then squared. 4 divided by 2 is 2. 2 squared is 4. So now we're going to follow those steps from up above. And this is going to just be, like we said, in order to solve by completing the square. So first we wanted to get the quadratic and linear terms on one side, possibly move the constant. So the constant number 5 is a 2. I want to subtract 2 on both sides. Now I have x squared minus 6x equals negative 5. So my quadratic and my linear terms are on the left, my constants on the right. Now I want to add the number that completes the square. So if I look at 6, and I take 6 and I divide by 2, and then I square it, 6 divided by 2 is 3. 3 squared is 9. So I want to add a 9 on both sides. So I'm going to have x squared minus 6x. I think I'm going to write the plus 9 in here, like that. So we're going to have x squared minus 6x plus 9. That's ready to be factored. And on the other side, negative 5 plus 9 is 4. So let's go ahead and factor. So I can factor this to Let's see, negative 3 times negative 3 is 9. Negative 3 plus negative 3 is a negative 6, so it's going to be x minus 3 squared. And then I could even write the 4 as 2 squared if I want. And now that I have it set up as a perfect square, I'm going to go ahead and take a square root on both sides. So when I have an x inside my square root, remember I have to have an absolute value. And then the square and the root over here, it's just a constant, so it's just 2. And then we have to allow for the fact that that absolute value could have two different things inside. So let's remember, when we take the absolute value of a positive 2, it equals 2. When we take the absolute value of a negative 2, it equals 2. So this stuff inside could equal a 2 or a negative 2. So I like to think about how, in order to get rid of the absolute value signs, we're trading in one of them for each equation, right? So the first absolute value I'm going to trade in for x minus 3 equals 2. And my second absolute value I'm going to get rid of by writing x minus 3 equals negative 2. So there's two absolute value signs, we write two equations. It's just something that kind of helps students. To solve, we're going to add 3 on both sides. So we get x is equal to 5, or on the second one, we would get x is equal to 1. So notice we're showing all of our adding and subtracting on both sides. Make sure that you show all of your work steps as demonstrated in class. So for our second one, we're going to start out by getting our constant term moved again, right? We want only, looking back up at our list here, we want to isolate just our quadratic and our linear terms, so possibly move the constant. So let's go ahead and add 40 on both sides. So now we have x squared plus 16x equals, this is going to be 57. Now our second step was that really weird new step, find the constant that will make a perfect square, and we do that by taking the linear coefficient and dividing by 2, so 16 divided by 2, and then we want to square that. So 16 divided by 2 is 8, 8 squared is 64. So we're going to add a 64 on both sides. And I'm doing that in like that different kind of purple color. Okay, our next step, if we look at our list, was we added the constant on both sides, then we want to rewrite it in factored form. Well, first I'm just going to rewrite it. So we've added it here. On the other side, let's see, 57 plus 64, that's going to be 121. And then I want to factor. So 8 times 8 is 64, 8 plus 8 is 16. So this factors to the quantity x plus 8 squared. And the 121 happens to be 11 squared. So we're going to square root both sides. So when I have a square and a root on the left-hand side, those cancel, but they become an absolute value because we have an x inside, and there's different values we could get for x that we could square and make positive. On the other side, my square and my root cancel. I only have 11. We could also have just said, well, we know the square root of 121 is 11. That's also possible. Now I want to write two equations. X plus 8 is equal to a positive 11, or x plus 8 is equal to negative 11. It might make more sense to write the negative equation first, but I find for my students, it's easier for them to write the positive equation first. We don't really care at this point as long as you're getting correct answers. So to solve, because we had a plus 8, we subtract 8. So x is going to be equal to 3, or x is equal to negative 19. So main idea today is this idea that not only do we have perfect squares, but we can use them to solve equations by this process called completing the square. And so we're going to be practicing this a lot today. As always, class, if you have any questions, please make sure you ask.